Okay, so welcome back to mathematics class. And now we were talking about surface areas and volumes, right? We were talking about surface areas and volumes. And let us see how much we had covered so far. We had talked about all the surface areas in our last class, right? We had talked about surface area of cuboid, cube, right circular cylinder, right circular cone, and finally a sphere. So we have completed the surface areas part, and now in this class we will look at the volumes. So we will start with volume of a cuboid, and of course then we will look at a cube. Then we will look at the volume of a cylinder or a right circular cylinder. Then volume of a right circular cone, and finally the volume of a sphere. So let us start off with volume of a cuboid. So let us see what actually volume is. What is volume? And volume is the three-dimensional space occupied by an object. The three-dimensional space, what do you mean by three dimensions? An object can have three dimensions, which are length, breadth, and height, right? These three dimensions an object can have. And whatever objects you are seeing in your daily life, all of them are three-dimensional objects. They have certain length, breadth, and of course a certain height, and they are occupying a certain amount of space on earth, right? So let us look at what is a volume of a cuboid, or how can we get the expression for the volume of a cuboid using the concept we had used in our last class. I think you can recall how we had made a cuboid. We used a thin sheet as the base, and then we had stacked upon several similar sheets one after the other, right? Now in this case we are looking at a thin sheet once again with length L and breadth B, and we are assuming that the area, which is L into B, is A, right? We are calling the area as A. Okay, so this area we are taking as the base area, as this is the base on which we are going to build our cuboid. So this is the base area. Okay, so now this time we are taking not exactly a thin sheet, but we are taking a sheet of thickness 1 unit, or a sheet of unit thickness, and we are stacking upon H similar kind of sheets. We are stacking upon H sheets, right? So the height becomes H. Now this shape has finally taken the form of a cuboid. Now what is the volume occupied by this object? Now if something has a base area, and we are trying to find out what is the amount of space it is occupying, then what we do, we multiply the base area with the height. We multiply the base area with the height, because base area has been stacked upon each other H times, right? If the base area of unit thickness has been stacked upon one after the other, then the volume occupied can be defined as the base area into height. The volume of a cuboid can be defined as base area into height. And what is the base area? It was length into breadth, right? Length into breadth was the base area, and here we have the height. We have the height here, so length into breadth into height gives us the volume of a cuboid. Okay, now so let us look at the volume of a cube. What is the volume of a cube? Cube, as we had learnt in our last class, is just a special case of a cuboid with all the dimensions equal. Length, breadth, and height all are of the same length, and here we have assumed their length as A. So what will be the volume of a cube? It will be the same, right? Length into breadth into height. And length of a cube is the edge. The breadth of the cube is also one more edge of the same length. And the height is yet another edge of the cube. So the volume of a cube can be defined as edge into edge into edge, or A into A into A, which gives us A cube. Right, so this is how we can find out the volume of a cuboid and a cube. So keep in mind, volume of a cuboid is length into breadth into height, or if we multiply all the dimensions, length, breadth and height, we are getting the volume of a cuboid. And for a cube, all these dimensions are the same. So let us talk about the unit. Now as we are multiplying three things of the same unit of length, the length is also measured in centimeters or meters, breadth also centimeters or meters, and height also in a similar way. So we are multiplying 3 centimeters or 3 meters. So our answer should come out in cubic units or meter cube or centimeter cubes, like this. Because in surface areas you had seen we were multiplying 2 units of length, either length into breadth or breadth into height or height into length, or any other factors which are having the units of length, right? We were multiplying at most two physical quantities which were having the units of length, and here we are multiplying 3 of them. So our units should come out in cubic units. So let us use this concept to solve one question. If the edge of each cube in the given figure, if the edge of each cube in this given figure is 2 centimeters, find the volume of the structure below. So it is given that edge of each cube, if we consider, for every cube the sides are 2 centimeters. So how will we find the volume of the entire object? Now if we can find out the volume of one unit which is getting repeated, if we find the volume of one unit and multiply that volume with the number of times it is occurring, we can get the total volume of the given figure, right? If we are multiplying the same unit the number of times it is appearing, if we add them all up, so we must get the entire volume of the solid given in this figure. So let us find out the volume of one unit, which is a cube. Volume of each cube comes out to be edge into edge into edge, like we had learned just now, and it is 2 into 2 into 2, which is 8, and mind the units, centimeters cube, right? 8 centimeters cube, cubic units. Now the number of cubes in this structure is 15, right? You can count the number of cubes. In this row we have 5, in this row 4, 3, 2 and 1. If you add them up, you will get 15. So if one cube has the volume of 8 centimeter cube, then 15 cubes must have the volume of 8 into 15 centimeters cube, right? It is simple unitary method. One cube's volume is 8, so 15 cubes volume will be 8 into 15, and units will be the same of that of the volume, centimeters cube. So finally we get the answer as 120 centimeters cube. This is our final answer. The volume of entire figure is 120 centimeters cube. Now we could have also done it in other ways, like we could have taken the rectangular strips. For example, we could have taken this entire rectangular part as one cuboid. This is one cuboid, this is one cuboid, this is one, this is one, this is one. So we could have got 5 cuboids with length. Accordingly we can add them up, add the number of cubes attached and find out the length. Then we got the breadth, then the height, and we could have multiplied them and added them all up. But this method, I think, is the simplest one, because we are just finding the volume of one part and multiplying it with the number of repetitions there, right? If the repetitions were not uniform, or if we had cubes along with some cuboids, then this method would not have been possible, right? As we are having here all the similar structures, so we are using we are finding out the volume of one unit cell, the volume of one cuboid, and then we are multiplying the number of repetitions that is there. So let us look at now the volume of a cylinder. Now I think you can recall what or how we had found out the volume of a cylinder, or the surface area of a cylinder, and how we had made it. We had taken a base area and stacked similar area or similar sheets on top of the other to form a big cylinder of height h, right? We had formed a cylinder of height h by stacking one after the other the similar base area. Now here also we are taking the base area with a thickness 1 or of unit thickness, and we are stacking upon h such units, right? So we are getting a height of h. So here also we are applying the same concept as that of cuboid for finding the volume, and here also we are using base area into height as the volume. So what is the base area? It is the area of the circular base, right? The base area is the area of the circular base, which is pi r square. Area of the base is pi r square multiplied with the height, which is h. So we get the volume of the cylinder, which is pi r square h, right? So the volume of the cylinder is pi r square h. So till now we had looked at the volume of a cuboid and the volume of a cylinder, which is pi r square h. So you can see here also 3 units of length have been multiplied. Radius has been multiplied twice and height has been multiplied once. So radius, if it is given in centimeters, and height also in centimeters, so we have centimeter square times centimeter, which is centimeters cube, right? So volume therefore always comes out in cubic units. So let us use this concept in a question. A stall keeper in a fruit stall has a large cylindrical vessel of base radius 14 centimeter filled up to a height of 32 centimeters with orange juice. The juice is filled in a small cylindrical glasses of radius 4 centimeters up to a height of 8 centimeters and sold for rupees 10 each. How much money does the stall keeper receive by selling the juice completely? So this is a big question, so let us break it down. First, we are given information about the vessel which is containing the orange juice, which has radius of the base as 14 centimeter and the height is 32 centimeters, and the vessel is of the shape of a cylinder. So we can easily find the volume for the volume of the juice available, right? We have found out the volume of the vessel or the volume of the juice inside it, right? Because the content of the juice will be the same as the volume of the cylinder itself, right? Because that is the volume it can contain. So we are having the volume of the vessel as pi radius square into the height 32. So the unit you can see centimeter cube, and here we are finally ending up with the answer as 6272 pi centimeter cube. Now you can multiply pi using the value 3.14 or 22 by 7 to this value 6272, but here we are not doing that, because in the coming steps you will see why we are not multiplying pi with this number. our main aim is to find out how many glasses will the shopkeeper sell, or how many glasses can empty the entire vessel. Because if we get the number of glasses which can empty the vessel, which is nothing but the number of glasses which could be sold, so that number when multiplied with the cost of one glass will give us the total amount of money that is earned by the shopkeeper, right? That is the amount of each glass, and the number of glass that is being sold when multiplied with the cost of one glass will give us the entire cost or the entire money which is received by the stall keeper. So we have got the volume of the vessel. Now similarly we can find out the volume of glass, which is again pi r square h. Now the radius of the glass is given as 4 square. So height is given as 8, and the units all are in centimeters, so we have the units as centimeters cube. And if all the units are not given in the same units, if all the units are not in centimeters, then you have to convert them into a single unit, or you have to convert everything in centimeters. Now luckily here everything is given in centimeters, so we don't need to convert anything. Volume of glass comes out to be 128 pi centimeters cube. Once again we have not multiplied pi here because we want to find out the number of glasses, and we are not actually interested in finding the volume, right? We are interested in finding the number of glasses. And how can we find the number of glasses? Number of glasses sold will be volume of the entire vessel divided by the volume of one single glass, because volume of one single glass multiplied with the number of glasses sold will give us the entire volume of orange juice which is sold, right? Volume of one glass times the number of glasses sold will give us the volume of the orange juice which is sold, and the volume of orange juice which is sold is equal to the volume of the vessel. So by simple algebraic calculations we can tell number of glasses sold will be the volume of the entire vessel divided by the volume of one single glass. And when you do this division, you can see the units cancel off, centimeter cube cancel off, and also here pi we can also cancel it off from the numerator as well as the denominator, right? We have cancelled pi from both above and below, so we are left with two numbers, 7200 divided by 128, and when this division is done we get the answer as 49, or the number of glasses sold is 49, right? So this way we get the number of glasses sold. And so the total money earned will be cost of one glass into the cost of one glass multiplied with the number of glasses sold, right? Rupees 10 per glass into 49 glasses, which gives us the total cost of the glasses sold, or the total amount of money earned by the stall keeper, right? So this is our answer, or 490 rupees is the amount which the stall keeper earns by selling the entire juice which is there in the vessel. So let us repeat the steps once more. First, we had found the volume of the entire vessel, or the volume of the orange juice which was contained in it. Then we had found out the volume of the glass, volume of one glass, or the volume of orange juice which is sold to each person. Then we are finding out the number of glasses sold, which comes out to be 49 by dividing the volume of entire vessel by the volume of one single glass. Then after we have got the number of glasses sold, we are multiplying it with the cost of one glass, Now the cost of one glass multiplied with the number of glasses sold will give us the total cost, which is the total amount of money which is earned by the stall keeper. So this is how we can use the concept of volumes to find out the solutions for such big questions, which actually seems big but is not if broken down in a systematic way. So let us learn about volume of a right circular cone. So how to find out the volume of a right circular cone, because the cone is not actually made up of stacking similar kind of figures, right? The base area is the maximum, and as we go up it becomes smaller. So how can we find the volume of a right circular cone? In surface area, you have seen that when we are wrapping something with a certain sector removed from a circle, right? A certain sector was removed from a circle, and then we were wrapping it around, and we had got a cone, and that is the method of finding the surface area. But we want to find the entire content or the entire volume of the cone right now. So how can we find it out? If we look at the base, the cylinder and the cone look similar, right? At the base, both the cylinder and the cone look similar. So they must have certain similarities in their volumes, right? So let us use cylinder to find out the volume of a cone. Now let us take the cylinder and the cone of the same radius and of the same height, same base radius, same radius. Let us assume the base radius of both of them are r, and the height is h. Now from the earlier question we have seen that the volume of a solid is nothing but the amount of liquid it can contain, right? The volume of a solid is nothing but the amount of liquid it can contain. So what we do, we take water and fill it in the cone, and then we pour it down to the cylinder to see how much fraction does it cover of the cylinder. So we see that it covers only a small portion. When we are emptying the entire cone into the cylinder gets filled up to a certain extent, but it does not get full or it does not overflow. So we get an idea from here that the volume of cone will be a certain fraction of a cylinder. So let us try this one more time to see that whether it is half of the volume of cylinder or not. So we have poured once more the entire volume of the cone, the entire volume of water which is contained in the cone. We have poured the entire volume into the cylinder, and we again see it does not fill up the cylinder. We have still some space left in the cylinder. So it again tells us that the volume of cone is more than the fraction of liquid which is contained in the cylinder, right? So let us do it one more time. Now when we are doing it the third time, when we are pouring the water contained in the cone for the third time, it is actually filling up the cylinder. So you can see, if a cone filled with water is emptied into a cylinder 3 times, then it completes the entire volume of a cylinder. So if the volume of one cylinder is 3 times the volume of a cone, then the volume of the cone must be 1/3 of the volume of a cylinder, right? Now pi r square h was the volume of cylinder, right? So you can see the volume of a cone must be 1/3 of it, right? This portion was 1/3 of the entire volume of the cylinder. So you can see how we have easily found out the value for volume of a cone by using a simple concept that volume is nothing but the amount of liquid that a solid can contain. So volume of a cone we have obtained as 1/3 of the volume of a cylinder, which is 1/3 pi r square h. So let us use this formula once again in a question. Monica has a piece of canvas whose area is 551 meters square, and be careful of the unit. Here the unit is meter square. Now she uses it to have a conical tent made with base radius 7 meters. So she is using the canvas to build a tent of base radius 7 meters, which is of conical shape. Assuming that all the stitching margins and the wastage incurred while cutting, this amounts to approximately 1 meter square, or the wastage which occurred during the making of the tent can be taken as 1 meter square, or 1 meter square of the canvas was wasted while cutting, stitching and all other stuffs, right? So we are left with only a certain amount of the canvas. After taking away the 1 meter square as wastage, we are using this canvas to build the tent. Now we are asked to find the volume of the tent that can be made with it, or the volume of the tent that can be made with the leftover canvas after considering 1 meter square has been wasted. So let us first find out what is the amount of canvas left with us. The area of canvas available for making tent is 551 meter square, which was there earlier, minus the amount which is wasted, 1 meter square. So we are left with 550 meter square of the canvas, right? We are left with 550 meter square of the canvas. Now we are using this entire area of the canvas to build a conical tent, right? And when we are wrapping the canvas, we are actually getting a conical shape, right? When we are wrapping the canvas, as we had seen in the last class, when we are wrapping the canvas, we are getting a conical shape, and for that conical shape, that entire area is nothing but the curved surface area of the cone. Now the surface area of the tent, as I told you, will be 550 meter square, right, which is the curved surface area of the cone. Now we know the radius or the base radius of the cone as 7 meters, and we also know the area or the surface area. So can we find out the lateral length or the slant height? So we are given the base radius of the conical tent is 7 meters, and therefore the surface area or the curved surface area of the conical tent can be taken as pi rl, where r is the radius and l is the slant height. Now pi rl is given as 550 meter squares, right? So after putting the respective values of radius and pi in these equations, we are taking pi as 22/7, radius is 7 meters square, radius is 7 meters, and we need to find what is the slant height. So by solving this equation, we get the slant height as 25 meters. By solving this equation, we get the slant height as 25 meters, right? So we have also got the slant height and the radius, but for finding out the volume, we don't need the slant height, right? Thus, for finding out the volume of a cone, it is nothing but 1/3 of the volume of the cylinder of same radius and height. Volume of a cone is 1/3 of the volume of a cylinder of the same base radius and the same height. So we need radius and the height and not the slant height. We need the perpendicular height, right? So To find that, we use the Pythagoras theorem as we had used in the last class. We know height square plus the radius square, height square plus the radius square gives us the slant height squared, right? Because if we are looking at the cross section of a right circular cone, we are actually seeing a right triangle with the hypotenuse as the slant height, the perpendicular or the vertical side as the height, and the horizontal side as the radius. So after putting the corresponding values and after taking all the known terms to one side and taking the unknown terms to one side, which is we are taking h at one side and l and r on the other side, and then we have taken square root so that we get h instead of h square directly. So we want to get h by doing square root of l square minus r square. Now we put the respective values of L we have got as 25 meters and radius we know 7 meters. So after calculating it, we get the perpendicular height as 24 meters. So now we know the radius or the base radius and the perpendicular height. So we can easily find out the volume of the cone, which is 1/3 pi r square h. Now we put the respective values and finally we get the answer as 1232 meter cube or 1232 meter cube. So this is the volume of the tent which can be made out with the remaining canvas. So let us go through the steps once more. So we had started off with a canvas of area 551 meter square, and 1 meter square of it was wasted while building or cutting for the shape of the tent. Now we are wrapping it to make the tent. So the surface area of the canvas is nothing but the curved surface area of the cone. And so we are equating the formula we know to the value given to find out the slant height. After finding the slant height, we use the concept of Pythagoras theorem to find the height, because to find out the volume finally we need to get radius and the height. So we find the height using Pythagoras theorem and we get the height as 24 meters. Now we know the radius as well as the height, so we can find out the volume of a cone, which is 1/3 into pi r square h, and by putting the respective values we get the final answer in cubic units, which is meter cube. So this is how we can use the formula or the concept for finding the volume of a right circular cone to solve different kinds of questions. Now let us look at the volume of a sphere. Now how can we find out the volume of a sphere? Neither it is stacked up with similar kind of base areas, and neither can we fill water into it, right? If we have a sphere and if we are creating an opening anywhere, then it is not remaining a sphere anyway, right? If we are making a hole on top, we are actually flattening the top, so it is not a sphere anymore. So how can we find the volume of a sphere? Now let us try to use another concept, and we are using the cylinder once again, but here we do not need to measure the volume of cylinder. So what we do, we fill the cylinder entirely with water. We fill the cylinder entirely with water. Then we take a sphere, a metallic sphere, so that it can sink into it. We find the metallic sphere, we find out its radius, right? We find out its radius and dip it into the cylinder. Now what will happen? Some of the water will flow out of the cylinder, right? Because the volume inside that cylinder is now getting occupied by a sphere instead of water, and the excess water which was there in place of the cylinder will now flow out, right? So what happened when we had put a cylinder inside, when we had put a sphere inside that cylinder? The volume of water which was initially occupying the space inside the cylinder, which is now taken away by the sphere. The volume which was contained inside the cylinder earlier by water is now replaced by the volume of sphere. So the excess volume which the cylinder cannot contain overflows, and we are collecting that amount of water which is overflowing in a separate container, right? So when we are inserting the sphere in the cylinder, the same amount of volume as the sphere, the same amount of water flows out. So if we measure the amount of water which has flown out, if we measure the volume of water, which we can do with any calibrated beakers, if we measure the volume of water, it should be equal to the volume of sphere, right? The volume of sphere, or the volume of water rather, the volume of water is actually equal to the volume of sphere, because that particular, exactly that amount of water has been replaced by the sphere inside the cylinder. And when it is found out, we can establish an equation based on our findings, and this experimentally comes out to be 4 by 3 pi r cube. The volume of a sphere therefore comes out to be 4 by 3 pi r cube, and of course, as you can see, it is r cube, so our units must come out in centimeter cubes or meter cubes. So this is how we find the volume of a sphere, and it is rather done experimentally than directly on the board. And of course, if we are finding the volume of a hemisphere or half of a sphere, then its volume will be half of that of a sphere, right? Half of 4 by 3 pi r cube, which is 2 by 3 pi r cube. So we know the volume of a sphere, and from that we can easily find out the volume of hemisphere. So till now we have seen all the figures, the volume of all the figures of which we had found the surface areas in the last class. We had seen the volume of cuboid, then a cylinder, then cone, and now finally a sphere. So let us use this, the volume formula in a question. A shot put is a metallic sphere of radius 4.9 centimeters. Right? A shot put ball, which is very heavy actually. It is a metallic ball, a metallic sphere, and this is of radius 4.9 centimeters. Now, if the density of the metal is given as 7.8 grams per centimeter cube, then find the mass of the shot put ball. So now, how to find this? We are given the density or mass per unit volume, or mass per 1 centimeter cube. So if we know how many centimeter cubes are there, or how much is the volume of the sphere, we can actually find out the mass of the sphere, right? If there is, suppose, 20 centimeter cubes of volume of the sphere, then 7.8 grams per centimeter cube multiplied with that many volumes will give us the entire mass of the sphere. So let us start doing it. Let us find out the volume of the sphere first. 4 by 3 pi r cube, right? So directly we can find out the volume by taking the radius as 4.9 centimeters, and we are approximating the value as 493 centimeters cube. We are just approximating it because it makes our calculations a bit easier, but it is not always a good idea to approximate values. Here we are doing just to make an estimate of the mass of a shot put ball. So our estimated value of sphere is 493 centimeter cube by using this formula 4 by 3 pi r cube. Now density, we know it is mass per unit volume. So mass must be density into volume. So by putting in the values, the value of density is 7.8 grams per centimeter cube, and the volume also we have got as centimeter cube, and after multiplying these two we get the answer in grams, and you can convert the answer into kg if it is too big. So we get the answer approximately as 3.85 kgs or close to 4 kgs. So here what we have done, to find out the mass, we actually need to multiply density with volume, and we are given the density and not the volume. So we have found out the volume using the formula of a sphere, which is 4 by 3 pi r cube, and we have found out the mass accordingly. Now be careful, whatever units is given here, grams per centimeter cube, you have to multiply the same unit on the other side to get rid of this unit of length to find out the mass. You can see, as it is centimeter cube, which is inverse of that, right? It is 1 by centimeter cube, and here we have centimeter cube in the numerator. So centimeter 1 by centimeter cube times the centimeter cube will cancel off, right? Because here we have the exponent as -3, here the exponent as 3, so they cancel off each other. So be careful while multiplying the density with the volume, both should have the same unit of volume so that they cancel off, and the unit of mass, it is actually coming out as the answer. The same unit of mass is coming out as the answer, and of course if the value is too big, you can convert it to a bigger unit or to a smaller unit otherwise. So you have seen, we have found the volumes of all the solid figures which we had talked about in the last class, and finally we have learnt about the volume of a cuboid, a cylinder, right circular cone and sphere. And let us recall the volumes once more. The volume of cuboid was length into breadth into height, right? It was length into breadth into height. Volume of cylinder was pi r square h. Volume of a right circular cone was 1/3 the volume of cylinder, right? 1/3 of pi r square h. And the volume of sphere, which we have just learnt, is 4 by 3 pi r cube. And all the units will be in cubic units, either centimeter cube or meter cube. And be careful, all the units of length must be the same. Length, breadth and height should be of the same units. Radius and height also should be of the same units.